This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Let's come back for the last hour of CS201, and you'll get rid from me, okay? And me from you. I'm joking. Please read the 11th question, try to understand it while I'm erasing the board, and then let's solve it together. So we are talking about the 11th one. This one. Read it and try to do it on your own. The program is easy, really. So what should we do is the following. This is about structures. We should define a structure for a car. And the fields, the elements, the variables inside the structure are the following. The brand, meaning BMW, Audi, Mercedes, whatever. The model, the year it's produced. Mileage, meaning how many kilometers or miles it has passed. Engine volume, and weight. So let's write this structure first. It's a structure. We are going to call it car. And it has the following fields. Brand. So what kind of type is brand? It should be BMW, Mercedes, Audi, whatever. So it's what? String. So string, brand. Then we have a model. Audi A5, for instance. It's again string. String, model. Year it's produced. It's an integer, it's obvious. Mileage, it's what? Integer also. We can say even it's an unsigned integer. But let us write it as integer. Volume, it's what? It's usually an integer. It's like 700 meter cubes or something like that. So it's an integer. Volume. Weight. Is it a character? Or a string? I am R-trim kilos heavy. It's an integer, the weight. Okay, this is for the structure. No, I mean, we don't go kilos, for instance. We don't go. I mean, my Mercedes is 5 tons and 2 kilos and 200 grams heavy. I mean, come on. We should write a function that takes a built-in array of car struct of this structure as a parameter and returns the total number of entries with engine volume that have engine volume greater than 1600. How are we going to do that? Basically, we take an array of struct car, and here we have all of those. I mean, we have the brand here, we have the model, we have blah blah blah, and we have the volume. If the volume is greater than 160, so let's say it's 500 here, and so on. We should check the volume. And this is a built-in array of cars. Let's say 100 cars. A built-in. How are we going to do that? We should return how many elements here have the volume greater than 160. So this is index 0, this is index 1, This is index, if we have 100 cars, 99. Now, if I have a variable of type car, and I call it, let's say, my car, how can I access the volume of it? Exactly. It's my car point volume. Okay, I access the volume. I access the model, my car point model. Now in this array, it's array not of integers, it's array of cars. How do I access this data here? This is the volume of the second entry. So we have the first entry, the second entry, up until the 99th entry. How I access the volume of the second entry? The name of the array is car. So first I should access this data here. How do I access that data? It's car of 1. Now I am here. And if I want to access the volume of that particular car, then point volume. This is it, okay? Is this clear? I mean, you should do it for your homework also. Is this clear or not? Very nice. If I want to access, if the name of the array is car, and if I want to access an arbitrary ith entry, and I do car of I point volume. Well, what I'm going to do, I'm start from 0 up until the end, and I'll see how many of those cars have a volume with a value that is greater than 1600. And I should return that value. So I'm going to write a function, and it should return an integer. It's the number of cars with a volume greater than 1600. It's going to be called, let's say, function. And this is important. We have seen how we send vectors as a parameter, but dynamic vectors. Now let's see how we send built-in arrays as parameters. We send them in the following manner. First, we send the type, and the type is car, since this array is consisted of cars. We send the name then of the array. Let's say it's array. And we write, open the parentheses, those middle parentheses, and close them, without any parameters. Meaning that we have an array. And since we have an array, which is a built-in array, we don't have the size property. That's why we should send the size as a parameter also. And it's an integer size. In our case, it's 99 or 100. But it's always constant, okay? With vectors, you don't have to send the size. But with built-in arrays, you should send the size. You must send the size because we don't know how long is the vector, how many elements it has, okay? We don't have the size property here. So, we define a counter. Initially, it is 0. And we start from the 0th index up until the end for integer I equal to 0. I is smaller than this size here. So here is the size, minus 1. I plus plus. What do? We check. If. How do we access a particular element? Array in middle brackets of I. Now we want to check its volume. So we have a certain, let's say this particular structure here, car structure. We want to see its volume. So array of I, point volume. If the volume is greater than 160, yeah, 1600. If it's greater than 1600, then what do? I increment the counter. Counter plus plus. This is it. So I check them one by one. Is this greater? Yes. Increment the counter. Is this greater? No. Continue up until the end. And in the end, I return the counter. Return counter. This is it. Let's go with the 15th example. Also, I would ask from you to do the 14th example. Try to do it, because we don't have time for today. Try to do it on your own. If you have any problems, just mail me. So this is the 15th question. Read it and try to understand it. And what we are looking here. And give me a way how to deal with that. Okay, did you read it? Did you understand what we're looking for here? Yeah, let me explain it also very briefly. This is what we're trying to do. So, I have here a file. This will be our input, a text file. And I'm saying hi. Point. Then I have some empty spaces here, and I'm saying this is CS201, and I'm writing by. I'm writing by again. Our job is to transform this input file into this one. So if this is the input, this is the output, another file. We write hi, all the empty spaces, but the first character after the dot, and this is important, the first character after the dot should be an uppercase letter. So, hi, this is CS201. If it is already an uppercase letter, it should remain like this. By, we have a dot here, a point, a full stop. We go to a new line, we see this B is also lowercase 1. We are converting it to an uppercase by again. This is it. So how are we going to do that? Well, I'm going to define a variable, a Boolean variable, dot exists. Initially it's false, F, false. So this is not dot, I is not dot. When I take the dot, I make it to be a true. And this means that if a dot exists, the next character, which is not an empty character, an empty space or a tab or whatever, it should be an uppercase. Meaning if it's a letter between A and Z, it should be an uppercase letter. So dot exists, but after dot exists I have here an empty space, I have a new line or whatever, but I write them as they are. At the first appearance of a character, of a letter character between A and Z of the English alphabet, I convert this guy to be to uppercase T, okay? And when I convert it, I made dot exist to be false again. Okay, so I take characters one by one still. I take this one, full stop. Okay, now it's true. I take an empty space, I write the empty space. I take B. This is, the B here is a character, a letter. But I write it as it is, because it's already an uppercase. I make this dot exist false. I take characters one by one. Oh, I came again here. I came to another dot, so it's true. Now I have a new line. You don't see it here, but it exists. It's a kind of an empty string, or I can say. I write it here also. When I take the first character, letter character, I convert it to uppercase. When I convert it to uppercase, dot exist becomes false. Okay? This should be our program. So let's write it. We should write what? A function, not a program. That's why we are writing the function. It says that we have already opened this input file, ifstream, and there was no problem with opening it. We have checked that, let's say, in main. And we have also opened this output file stream. We don't have any problem with this one. And we also assume that the header is at the first character here. So we are in the beginning and reading it. And also, we are in the first character here. We don't have any text here. It's empty, basically. And we try to take character by character and put it here with the formula that just I told you, with an algorithm that I told you about. So this is a function. It's void. The parameters that I take are ifstream. Always they are sent as a reference. ifstream in file. So this is in file, not the text itself, not the file itself. Okay, the ifstream data, and part of that is this file. We have also other member functions like get character, what else, arrow, whatever. Also we have the ofstream reference for this guy here, out file. The name of that variable is called out file. So this is the out file. We define a new character that we are going to take. We define the Boolean value that I just told you about, dot exist. Initially, it's false because we still didn't get any character from the input. And now we are getting the characters one by one. You remember the get char function get ch. It takes character one by one up until we come to a character which is called end of file. When we take this character end of file, that means that we cannot take files anymore. So while from this input file we can get characters, we put them to this ch here. Actually it's only get, not get char. Get char is part of C. In C++ it's get only, so get ch. This is what we do. The first thing we do is we check whether the character we have just taken is a dot. So we ask if the character is equal to a dot. If the character is dot, then dot exists becomes true. So dot exist becomes true. And of course, if it's a dot, we write the dot also. That's why we do it with the out file. And out file, you remember, I'm not going to write the properties, member functions of that. I've written them like 2 or 3 times in the recitations. So out file, this is how we write an output with this OStream operator and write the character, which was the dot. Okay, if it's not a dot, what do we do? Else, if we check, for instance, we have taken dot and it's true, and now we check whether if we have taken a dot, then what should we do is the following letter character should be converted to an uppercase, okay? This is the part we're writing right now. So if it's not a dot, we check whether dot exists is true. If it's true, that means that we have taken a dot and now we have to convert the first character to a letter uppercase. That's why we ask else if dot exists and let's see what are we doing here. Now, if the character that we have already taken is a letter, and how do we express it? How do we say to the compiler if it's a letter? You remember the Ascii table? So letters were what? Greater than A and smaller than Z. Greater or equal to A and smaller or equal to Z. Let me refresh your memory if you want. So the Ascii table here it is. And you see that letters are here from A to Z. Meaning if it's a smaller case letter from A to Z, we should convert it to uppercase. And this is how we're going to do that, okay? So if we have seen a dot and we have written those empty spaces here, then we should convert it to uppercase. Meaning that if the character is greater or equal to A or smaller than equal to Z, meaning in that range here, and you remember from like a week or 2 weeks ago, those are converted characters into integers, and those integers correspond to the ASCII values. Okay? So when I say the character is greater than or equal to A, that means the character is greater or equal to 97, and the character is greater or equal to 122. And that character itself is an ASCII value here. Okay? We have seen that, I think, last week, if I'm not mistaken. So if the character is a letter, meaning between A and Z, greater or equal to A, smaller or equal to Z, and characters are written with quotation mark, single quotation mark. If it's the case, then what should we do? We should convert this T, this lowercase letter, because these are lowercase, you see? We should convert it to an uppercase. How do we do that? You can use the string utilities. There is the function toLower, toUpper, and so on. Maybe this is a better way to do it. But we can do it using the Ascii table as well. You see the value of the lowercase a is 97. And of the uppercase A is 65. Okay? So, in between, what's the difference between them? It's minus 32. Okay? B and capital B and lowercase b is also 32, also 32. Okay? So, kind of we subtracted. Well, this is the stuff we are doing here. So, if it's a lowercase a, then we should subtract it. And this is the way how we do it. Out file, we print it to the out file, we send it to the out file, with the arrows. But we should print the character. Basically, we can say the character minus what? Minus 32. We can do it. But also, we now know that that value is 32. But if you're not sure what's that value, you can say character minus a minus a. Because a is 97, lowercase a is 97, uppercase a is 65. So 97 minus 65 is 32, if you don't remember this 32. And this is what we are writing here. So it's the character minus 32, and that 32 is a minus a. Okay, so this is 32. Meaning, if we are sure that it's a capital or lowercase letter, we should subtract it by 32 to get the uppercase letter. And 32 is done like this. Character minus 32. Is this clear? Because a minus a, uppercase a minus lowercase a is 32. If you don't remember the distance, between a lowercase and uppercase letter, there are 32 characters in between, okay? So if this is the case, we'll print this one. However, if it's not a character, if it's an empty string, or if it's an empty space, or a tabular value, or a new line, or whatever, then we just print it as it is. Meaning, so this is for this one. We continue, else. This else is for this if. If it's not a character, else, if the character that we have already seen is equal to an empty space, this is how we write an empty space, or it's equal to a tab value, this is how we write the tab, or if it's a new line, this is how we write a new line, then just, what should we do? If it's an empty space, we write the empty space. If it's a new line, we write it. If it's a tab value, we write it as it is. That's why we can just write something like this. Out file, the character. Else, what is remaining? I mean, we are sure that the characters here are either dots, new lines, tab values, and lower uppercase letters. So what do we have else here? We don't have numbers. Or even if we have, numbers, we have uppercase letters. If it's the case, what should we do with that? Exactly. Else, just write them. Out file, the character, meaning that if the dot exists, we have dealt with this one. We have dealt with this one. And the dot exists becomes 0. I mean, false. This is it. This is for this else. This is for this else. For this guy here, we close the brackets here. And this is it basically. Yeah, if dot exists, we are doing this. But if dot doesn't exist, okay, so we are finished with this stuff here, Else, again, let's say we are taking C as numbers also too. We just append it like it is. I mean, you can write it in a better way. You can write this program in a better way, but this function also, the way it's written here, also works. So out file, character, and this is it. Void. Yes? No, we should make it here false. It's okay. So this is the program. Even if you make it here, it would be better, but the program is still going to work. Because if you convert it from uppercase, from lowercase to uppercase, this is it. You don't have to bother anymore. But it still will work. It's not... Again, I mean, it's better if you write your programs on your own, from scratch. I'm sure that maybe you can come with a better way of writing this program. Okay, but the algorithm is the one that I told you about in the beginning. This was the 15th question, and we have 2 more to write. Let's go namely with the 16th one. It's an easy one. So the 16th question, let me find it. Okay, read it, try to understand it, and give me an idea how you were going to write it if you were in an exam. Okay, so we should write a program. So you want to count the number? Okay, nice idea. Let me explain for those that couldn't understand what we are trying to do. So this is our input. Well, let's say we have here a text, line 1, blah, 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 blah. Then we have line 2. Then we have line n minus 1. And we have line n. This is our input. Our output, we should transform this to this output. Should be something like this. So this is the output. It's also a textual file. We should write all of the lines except for the last line. Okay? So basically we should have here line 1 and everything else up until line n minus 1. We shouldn't write the last line. How are we going to do that? So you want to count the number of lines, and then you count the lines, then you go again from the beginning. If you have n lines, you just iterate at minus 1. Very nice. This is one way of doing things, but this is the problem with your algorithm is that you should take all of the lines, use sig_0 to go in the beginning, and then only iterate it n minus 1 times, counter minus 1. So you should iterate it twice. Can we do it in a better way? What do you think? You thought the same. Okay. Sometimes the algorithms that we give are better, sometimes your algorithms are better. But let's do something like this. I have 2 strings, so one line is basically a string, which is called previous line, and another string which is called current line. Initially, let's assume that our output file is empty. We don't have anything here. So what I'm doing is the following. I'm using the getLine function. I take a line and put it here. So this is line 1 until the end. Then I use getLine again, and I put line 2 here, up until the end. If I can get the second line, then I put the line 1 here, the previous line here. So I'm printing line 1, okay? And I'm erasing, I'm putting line 2 to be a previous line. So here is line 2. And I'm getting the third line. I'm putting it here. So line 3. If I am getting the third line, then I'm putting line 2. Basically, if I can get a new line, I'm putting the previous line in the output. So I'm getting lines one by one. They will be, everything will be put here. I have line n minus 1. Okay, I've put it here already. Then I put line n here, line n, the last line. I didn't put it to the output. And I'm trying to get another line here, but I cannot get it. Since I cannot get it, I don't put the last line here. Okay? So I don't have to iterate it twice to count the number of lines and go to the beginning and write them. I just go, if I can take a line, I put the previous line to the output. This is it. So we are asking for a program, not a function, and I'm going to write it from scratch. So I include everything that we need. Probably this is not going to work during the exams. You should write that you need here the IO stream, the file stream, IF stream, OF stream, the string, namespace, and so on. Using namespace also. This is going to be a void main. I have two strings for the file names, namely they are input point txt and output point txt. Let's assume their names are like this, but we will ask from the user to give the names. So I have two strings, file name 1 and file name 2. I'm asking the user to give the names. Okay, enter the names of the files for the input and for the output with a new line in the end. The user gives both of them. So cin file name 1 and file name 2. It is told in the text that I don't have any problems with opening the file, so I don't have to check if open, if close, if failed, if... I'm sure that I can open both of them. That's why I declare a new IF stream, which is going to be called in for input, and I open the input in point open file name copy string. File name 1 point copy string. I declare an output file stream for this guy here, OF stream. It's going to be called out. I open it also. So out point open file name 2 point copy string. Now I'm defining those strings, previous line and current line. So string, previous line, then I'm using the getLine function to get functions, and if I can get a function, I'm writing it to the previous line. But first I get the first line here, so I'm using the first getLine for the first line. And you remember getLine takes an input file stream, a reference to it, and a string where we put the line we have read. So this is the previous line, and I have the data here. Then I define another string. Let me do it here better. So I'm continuing here. another string which is called current line. And this is what I'm doing. If I can get a new line, while get line from the input file, and I put the text to the current line, if I can do this, then obviously I output the previous line to the output. So out, previous line, and I also have a new line. Can you tell me why I'm writing a new line? Because the getLine function doesn't take the new line, okay? It takes everything up until the new line. That's why if you want to be the text to be exactly the same without the last line, we should have the new lines, and we should have them here like this. And of course, what do we do here? So when I put the previous line here, the current line should come here to the previous line. That's why I say the previous line is equal to the current line. So I read one. If I can read it, I put it here, and the thing that I have just read, I put it here. So if I can take another line, I put the previous line, I put it here. Okay. So previous line is equal to the current line, and this is it. In the end, you close the output file, especially the output file is important to be closed. End of the program. This is for main. Any questions? Did you understand it? Okay. Now let's go with the 17th example. I think it's the last one for today and for the course. Just read it, try to understand it, and let's do it together. If you don't have question, I'm going to erase this piece of code. Okay, did you understand the code or not? As an input, we have a file like this. In each line, we have the name of a city, an empty space, and its population. Okay, it's like that. The format is clear. We don't have to do any other checks. Our job is to write a program where we should give an input, name of a city, and we should check whether that city appears here. If it appears here, we should write the name of its population. For instance, if I'm asking for Istanbul, I should check, okay, Istanbul, Istanbul, okay, I found Istanbul. Then I know that the first word of the line is the name of the city. I have an empty space. The second one is the population of that. So I should output that the number of inhabitants in Istanbul is approximately 10 millions. I think this is an outdated one. It's like 20 millions, okay? If I don't find the city, let's say I'm giving a Skopje. Have you heard about Skopje before or not? Who has heard about Skopje? You? Okay, it's my city where I live. It's in Macedonia. So if I'm looking for Skopje, for instance, it's the capital of Macedonia, and if I don't find it here, then I should print unknown. Unknown, is it okay? With capital letters, unknown. So it's an easy program, I think. Okay, and these are what makes it easy is the structure of the input file. Well, we have always the name of the city, empty space, population. So basically, we can get them with get line, and then we can separate them with iString stream. You remember iString stream? And word 1 is the city name. Word 2 is the population. It's as simple as that. Let me write the program. We should write a void function, basically, not a program from scratch. So I'm doing it now. Void display is going to be the name. Display population. It takes 2 parameters. One of them is IF stream, a reference to an IF stream. I'm going to call it input. This is the input file. And it takes also a string, which is going to be called search name. Basically, this is the city we are looking for. Search name. This is the city. We define some strings here, namely line, then city, then population. Line is for taking the whole line, then dividing the line in city and population. So I'm going to use this line in the getLine function. Initially, search population is going to be it's also a string. It's going to be unknown, meaning search name should be one of the cities there. If I find it, then the search population will be one of those cities there. If the search name that I've given as a parameter doesn't appear, it's going to be population of that city is going to be unknown because I don't have it. Okay, it's string. Yeah, you might see it as an integer, but we are going to see it as string because we don't need it as for iString stream. We should have strings always. So this is unknown. Meaning if I don't find the name of the city, the population of that city is unknown. I should be, so this is input, clear, 0. I should be sure that I don't have any mistakes. And I should start from the beginning with sig_g, because, pay attention, in the previous example we said we are sure we start from the beginning. The header is pointed to the beginning. We don't say it here. That's why we might have mistakes from previous iterations. And we might not be in the beginning. That's right. Don't forget to write this one in your exam. Input sig_g. We start from the beginning of that file. And we are getting the files. The lines. So while if we can get line, and you remember the getLine function returns true if we can get the line. Okay? It, of course, stores the line it just took from the file into the string. In our case, it's going to be the name of the string line. But also returns a value which is true if it successfully took a line and stored it here. Otherwise, it returns false. So while we can get lines, we have them in the line, but we know that each line is consisted of the city name and the population. That's why we're going to define an iString stream. We are going to call it string line, and it takes the line as a parameter. And we are going to take words one by one. We have 2 words in each line. So one word goes for the city, and the other one goes for the population. we do it like this. Since we are sure that there are two words, the first word goes to this like an input. Okay? The first word goes to the city. The second word goes to the population. Okay, I'm continuing here. Now, I have the city, and I want to check whether the city that I've just read is equal to the search name. So if the city is equal to the search name that I've provided as a parameter, then I have a match. And the search population is not unknown. It's going to be population. So search population now has a concrete value, and it's the population of the city we have found. So it's population. This is for the while. In the end, we print the city and the number of populations in that city. So, cout the population of, now we are printing the city search name we have been looking for. Is, now we are printing the search population. If it's unknown, we'll say, okay, the population of Skopje or New York is unknown. Otherwise, the population of Istanbul, for instance, is approximately 10 millions. We keep it in the search population. We don't have to return anything. So this is for the function. Any questions about this guy? Yes or no? Is this clear? Yes or no? Okay. Just pay attention to this iString line. Usually we have used it with another while loop. But in this case we are sure that each line is consisted of two words. One of them is the city, and the other one is population. That's why we can write it like this. Okay, guys, this is all for CS201. If you don't have any question, you were an excellent auditorium. It was my pleasure to be your TA. Our friendship continues, of course. If you have any questions, what kind of questions about programming or even for the CS department, you know my office, you know my number, you can mail me, you can come to my office, and I wish you all the best. I'm sure that many of you will be future TAs, future university professors, engineers, and so on. So I wish you all of the best in the world. Thank you.